Hi everyone, and welcome back to Fundamentals of Engineering with Farhad, Mechanics of Materials. In this example, we have like an aircraft tow bar, which is handled with a hydraulic cylinder at the beginning, then is connected with the help of a 25 millimeters steel rod, which is this green part here, to a two identical arm and wheel units like DEF. If we know the mass of the entire tow bar is 200 kg, and then the weight applies at the center of gravity. We want to know what is the normal stress in the rod. To solve such problems, we need to draw an accurate free body diagrams for the entire system as well as the parts. So to do so, first we will draw the free body diagram for the entire tow bar system, and as soon as you do that, you can easily see the external forces like AX, AY at the pin, like the weight which applies at the center of gravity, and R which applies at the wheel at point F. So summation of moment about A goes zero, it just cancel out these two forces, and because we already know what mass is, multiply that by G to get the weight of the entire system which applies at the gravity center, and the only unknown of the problem is R, which is simply calculated. And then if we just draw the free body diagram for the DEF part, arms and wheel unit, then you can easily see R, which we already calculated, is applied at F, then EX and EY apply at the pin, and the tilted force of FCD with the angle of alpha applies at the point D. Then this time summation of moment about E goes zero, cancel out these two forces, and then we can get force of a steel rod CD. Then as soon as we have the force, divide that by the area of the rod, we can get the normal stress inside the steel rod CD, which we are looking for. Now it was the big picture of the problem. Now let's jump to the details of calculation. To do so, first jump to the free body diagram for the entire tow bar system, and then summation of moment about a point A goes zero to get the uh, force at R, force R at F. We do know the mass of the entire tow bar is 200 kg. Multiply that by G, which gives us the weight, and so W is M times G, and it just gives us a W, or weight of the entire tow bar, is 1962 newtons. So as soon as we have the W, the only unknown left is R, and summation of moment about A goes zero, it just gives us what R is. To do the math, you can easily jot down the forces times their distances. Summation of moment about A in a counterclockwise situation goes zero, and then you can like have R times 850. R times 850, we already know what W is. We are looking for R right now, times 1962, which is W, times the distance from A, which is 1150 millimeters. There is no other force applies there. Then it just gives us R is equal to 2654.5 newtons, or 2654.5 in newtons. As soon as we have R, now we get the all the unknown in the entire tow bar. Now we need to move to this part like DEF. So for arm and wheel units, let's jump to the second part, or the second part free body diagram. So R, which we already calculate, that one is applied at point F on the wheel, then at the pin E, EX and EY applies, and the tilted force from rod CD which we already see in the entire system, with the angle of alpha applies at the point D. So if we calculate the alpha here, alpha is tangent inverse of a 100 rise over run, which our rise is 100 millimeters, our run is 675, and it just gives us alpha is 8.4 degrees. Summation of moment about E goes zero, it just simply get FCD times cosine of alpha, FCD cosine of alpha, because the vertical component just passes through E, but the horizontal one makes a moment. So FCD cosine alpha times 550, which is this distance, 450 plus 100, then minus r times 50, which is we already calculated what r is, times the distance. It just gives us F sub CD is equal to 2439.5 newtons. As soon as we know the force at CD, which is like FCD is equal to 2439.5 newtons, and then simply by dividing the force over the area of CD, which is provided in the figure, it just gives you the normal stress is equal to negative 4.96 times 10 to the 6 Pascal, and that's what's happened inside the steel rod. DC FCD is known. Calculate that one divided by the area, which is a 25 millimeters rod, and it just gives us a sigma CD, or normal stress is CD, is compression. That's why we have it like a negative. Then for negative 4.97 megapascal. Thank you. We'll solve more problems related to stress calculation. Thank you.